Welcome to EDU World Space.
24.32, we have a non-uniform distribution of charge along the x-axis extending from 0 to 0.2 meters. We're given this proportionality constant of the charge density, and we want to find what the potential is at the origin and at 0.15 meters up the y-axis, assuming as usual that the potential at infinity is 0. So this is going to be, pretty standard integration deal. Add up each of the dv's and we get our total v. So here, r is just equal to x because x is greater than 0, so there's no absolute value nonsense or anything we need to do, blah, 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 blah. So then v is going to be equal to 1 over 4 pi epsilon naught times the integral from 0 to 0.2 meters of dx dx. And in all cases, both cases, dq is going to be dx dx. This is lambda dx over x, so that cancels. So we have just the length of 0.2 meters times b divided by 4 pi epsilon naught. That gives us 36 volts. So that was nice and straightforward. Now we're not quite so lucky. Let's call d the y-coordinate, and that's a fixed 0.15 meters. So now r is the square root of x squared plus d squared. So we have our 1 over 4 pi epsilon naught and so now our integrand is dx dx over the square root of x squared plus d squared. And so then doing this integral, we get b over 4 pi epsilon naught times the square root of x squared plus d squared, evaluated from 0 to 0.2 meters. And then plugging in the numbers and taking the appropriate difference, we get 18 volts.